This is a fun geometry problem from the 1953 American High School Mathematics exam. We're given this triangle ABC with a base length of 15. Then, two lines are constructed on the two sides of the triangle such that they're parallel to the base and such that the three sections they create, so this section and this third section, are all equal in area. So you can see all that information written here. These two lines are parallel to that base, and the areas of these two quadrilaterals are equal. They're also equal in area to this triangle at the top. So these two lines have split up the triangle into three sections with equal area. Now the question is to find the length of the line closer to the base of the triangle. So the length of line DE. We're going to do this using triangle similarity. We have parallel lines here, so there's a lot of angle congruence that we can identify. This angle here is congruent to this angle because they are corresponding angles. You've got a transversal that's cutting through these parallel lines, so those two angles are congruent. Same thing over here. These two angles are congruent because you've got parallel lines being cut by a transversal. And then this angle at the top is shared by all of the three triangles that you might notice in this problem. The two triangles I'm focusing on right now are the big one, and clearly we can see it's similar to this smaller triangle because all of their angles are congruent. So writing this out, triangle ABC is congruent to that medium-sized triangle, triangle DBE. This, of course, means that the ratios of their corresponding sides are equal, but it also tells us about the ratio of the areas. Whatever the ratios of their sides are, the square of that is the ratio of their areas. That's just another relationship between similar triangles. So I'll put the ratio of their areas over here on the left. It's pretty easy to figure out, so we'll write it in a minute. But it's going to be equal to the square of the ratio of two corresponding sides of the triangles. For example, the side DE that we're interested in corresponds to the base of the bigger triangle, which has a length of 15. So the square of that ratio, the length of side DE to 15, the length of the base of the bigger triangle, the square of this ratio has to equal the ratio of the areas because they're similar triangles. Now, what is the ratio of the areas? Well, the big triangle is made up of three of these equal area sections, and the smaller triangle that it's similar to, this one here, is made up of two of those equal area sections. So the smaller triangle must have an area that is 2/3 of the bigger triangle, because the smaller triangle has 2 out of 3 total pieces. So this ratio on the left is 2/3. So 2/3 equals the ratio of the corresponding sides squared. Now you can see how we're going to be able to solve this for the length of DE. Let's write the DE part of this equation on the left. So we have the length of DE squared divided by 15 squared, because we have to square this whole thing. 15 squared is 225, and this equals, on the left, 2/3. Now let's go ahead and multiply both sides of this equation by 225. So we have that the length of DE squared is equal to 450 divided by 3. We can reduce this fraction. 3 goes into 450 150 times. So this equals 150. And now, to finish solving for the length of DE, we just take the square root of both sides. So the length of DE that we're looking for is the square root of 150. Clearly, we can simplify this square root because 25 goes into 150. So let's take 25 out of the square root. The square root of 25 is 5. 25 goes into 150 6 times. So we have 5 times the square root of 6. And that is our final answer. The length of this line closer to the base of the triangle, the big triangle, that line must have a length of 5√6. It's maybe a little confusing that I put all of this in green, even though the line that we're looking at was drawn in blue, so I'll just change the color to blue there. Hope that helps. Let me know in the comments if you have any questions, and if you want to see some more interesting math problems, check out my playlist in the description. Thanks for watching.
I'm the mathematical menace, the machinations of mankind. Two calculators at the same time, hand signs and abacus, finger count and calculus. I'm a V to the T, my parameter, the rapidest. Happens like this, my lecture's the most prominent, dominant. Call me De Morgan, I get the compliments. The union in together like any time that we intersect, cause my opponent